This lecture's going to go over some key definitions between matter and energy. And so recall from last lecture, we defined matter as anything in the universe that has mass, anything that occupies space, anything with a physical presence, or anything you can touch, taste, or smell. And energy is the ability to do work. And we'll come back to this definition in a couple minutes. Work is then the amount of energy required to move an object a given distance. And when we talk about chemistry, we're talking about the study of the composition, structure, properties, and transformation of matter. And so we can look at this a little bit closer, and we'll start off looking at matter. When we think about matter, matter is what's around us, all around us in the world. And we usually classify matter into three different forms: solids, liquids, and gases. And we're all familiar with these, but we can put some specific definitions in this. And a solid, like the snow shown here, has a definite size and shape. And this is independent of the size or shape of a container. So the analogy I like to give is an ice cube plunked into a glass. An ice cube has a definite size and has a definite shape, regardless of what type of glass you put it in. A liquid, by contrast, has a definite volume, but takes the shape of the container. So if that ice cube melts and becomes a liquid, it's going to take whatever the shape of the container is, but it still maintains a definite volume. And a gas, shown here, a picture of a gas molecules will take the volume and shape of whatever container they're in. So gas molecules will always just spread apart as far as they can sort of be in whatever space they are in. Now, we can start to ask the question of, well, what is matter actually made of? What is matter? And this question was postulated going all the way back to ancient Greece. Aristotle and Plato thought matter was continuous. And what we mean by this is you could keep cutting a piece of matter in half and in half and in half again and again and again. And you could do this an infinite number of times. You could just always keep splitting matter apart. Democritus, however, said he proposed that matter instead was made up of tiny fundamental particles that are indivisible, and he called these atomos. This is where the word atom comes from. The idea that we have a fundamental building block that is the atom. And today, we know that this to be true. The atom is our fundamental building block, and we can actually start to image or start to see individual atoms using microscopy. And if we use a scanning tunneling microscope, we can start to see the first ever images of individual atoms. And so here's a couple of pictures, some recent pictures of surfaces. So this is a platinum structure, and here we have a platinum atom and a platinum atom. You can see a surface of nickel metal. So these are all, each bump would represent a nickel atom. And more than that, we can start to manipulate these things. And here we have surfaces of iron where chemists and physicists have gone in, and we can start to even draw shapes on the surface of the atom to add a single layer of atoms in a particular shape on a surface. So we're starting to be able to see and manipulate these things on the atomic level, which is really exciting. So put some definitions to things. The atom is the smallest particle of an element that retains the chemical characteristics of the element. A molecule, by contrast, is a collection of atoms that are chemically bonded together. And a chemical bond is nothing more than the force of attraction that's holding atoms together. So we can look at something like water, which we're all familiar with. So here's a picture of water in the liquid state. We also know water is H2O, and what we're talking about there is it's composed of 2 hydrogen atoms and 1 oxygen atom. So it's made of 3 different atoms that are held together by bonds that are keeping those atoms moving together as a single unit. All right. One important thing to know is matter can be transformed from one state of matter to another. And we've seen this a lot. We can think about how many different phases of matter and phase changes we can think of. And if we come up with it, we can say Solids can be converted into liquids through a process that's called melting, and a liquid can be converted into a solid by freezing. Liquids can go to a gas through vaporization, and gases can go back to form liquids through condensation. We can also, in some cases, go directly from a solid straight to the gas through what's known as sublimation. This is why if you leave ice cubes in your freezer, the ice cubes will disappear over time. Where did they go? To solid ice, became a gas. And we can have the reverse, where a gas can become a solid through deposition. The other important thing to know is anytime we're changing a phase of matter, accompanying that change is a change in energy. And when you're looking at this diagram, as you move from left to right, it takes energy. So we have to put in energy to melt a liquid, and you have to put in energy to boil a liquid into a gas. If you're going in the reverse direction, energy is released. When we think about energy, we can think about two types of energy. We distinguish between kinetic and potential energy. Kinetic energy is the energy of an object in motion due to its mass and speed. And while we won't use this equation in this course, if you're taking a physics course, you may recall that the kinetic energy is equal to 1/2 the mass times the speed of the object. And the potential energy is the energy stored in an object due to its position or composition. In our case, when we think about potential energy, we're going to be thinking about the energy of bonds, of storing those energies. And we can think about that as calories. When people look at nutrition labels and count calories in food, that calorie number is really a count of the potential energy of that food. Okay. So let's come back to our definition of energy. We said energy is the ability to do work or produce heat. And work is force acting over a distance. So for example, work is equal to force times a distance. So pushing an object and moving it some distance is work. Heat, however, is the energy that flows from one object to another because of a temperature difference. And the difference between work and heat is work is directed, right? We push an object from one place to another, right? That's a directed energy. Heat is going to go in all directions, right? So heat's going to flow from one object to another because of that temperature difference. The law of conservation of energy says energy cannot be created nor destroyed, but it can be converted from one form to another. And a lot of times when we're dealing with energy, what we're trying to do is maximize the amount of work that we can get something to do and minimize the amount of heat. Some common units of energy that we will see: the joule, the calorie, and, while a little confusing, the capital C calorie. Notice there's one calorie unit that has a lowercase c and one unit that has a capital C, which is equal to 1,000 little c calories. All right. When we think about our matter, we can think about classifying matter as a pure substance or a mixture. So a pure substance is something that cannot physically be separated into different components. Well, a mixture is something that we can separate into components. And so we can think of our little flow chart here. If you have matter, we can ask ourselves, can it be separated by a physical process? No, it must be a pure substance. If yes, it must be a mixture. So we start on the pure substance side. We have two different types of pure substances. We can say, can that pure substance be decomposed by a chemical process? If the answer is no, then we're dealing with a pure element. If the answer is yes, we're dealing with a compound. And a compound is made up of multiple elements, and so we can separate those into the individual elements. Over on the mixture side, we can think about two different types of mixtures, and we often call them as homogeneous mixtures, where the mixture is uniform throughout, right? So in this case, we have a bottle of vinegar made of acetic acid and water, right? But it looks the same throughout, and so that's a homogeneous mixture. And a heterogeneous mixture is something like salad dressing, oil and vinegar, where you clearly have multiple phases of matter or multiple parts that are separated. So we have solid chunks, we have liquid chunks, and we have more aqueous liquid down here. So difference between an element and a compound is a pure substance that consists of two or more elements that cannot be physically separated from one another. An element is a substance that cannot be separated into simpler forms. So an element is really our sort of simplest form of matter. So for example, an element, we can think about gold or sulfur. So both of these, gold in this case and sulfur in this case, have made up only a single element, a bunch of gold atoms or a bunch of sulfur atoms. And thinking about a compound like water is made up of oxygen and hydrogen, so two different types of elements. And while physically we can't break it down, we can chemically separate this by breaking the bonds and separating oxygen from hydrogen. And finally, we'll leave with one more property of matter. We just want to distinguish quickly between what's known as an intensive property and an extensive property. An intensive property is a property that is independent of the amount of substance, and an extensive property is one that varies with the amount of substance present. So, for example, we can look at a couple of properties and decide, are they intensive or extensive? So we can think about gold is malleable, meaning it's bendable, and ductile, meaning we can stretch it into wires and conduct electricity. And we think about the fact that a gold brick has a mass of 1 kilogram. So when we think about these two properties, the fact that gold is malleable, that means that we can bend it and shape it. This is an intensive property, in that it doesn't matter how much gold we have, whether we have a couple grams or a couple kilograms or 1,000 kilograms, this is going to be true. We can bend it, we can stretch it. Whereas in this case, if we're given a specific mass, the mass of gold is an extensive property, because that mass is determined by the amount we have. So we'll end this lecture there. Thank you for listening.